We showed in Chapter 9 that along any own price demand curve, we hold the prices of all other goods and income fixed. In other words, we hold all the economic circumstances other than the price of the good that we're modeling fixed and illustrate how the consumer's quantity demanded changes as that good's price changes. Now we've introduced a compensated demand curve, or what we've also called a marginal willingness to pay curve. And we've seen that income doesn't enter into the formation of the compensated demand curve. Rather than holding income constant along this demand curve, we hold utility constant, because we assume that the consumer always gets enough compensation for price changes so that she stays on the same indifference curve. We'll try to further clarify this here. We begin with an initial blue budget constraint incorporating a price P1 bar for the good X1. Notice that we're modeling the good on the vertical axis as dollars of other goods, and so we're implicitly setting the price of the good on the vertical axis equal to 1. Our optimal bundle under these economic circumstances is bundle A, and we label the indifference curve that's tangent at bundle A as the indifference curve that we can reach at income level IA. Next, suppose our income level falls without any change in prices, giving us the new magenta budget constraint. Our new optimal bundle is then bundle B, and again we label the indifference curve that's tangent at B as the indifference curve we can reach at income level IB. In the lower graph, we measure the price of good 1 on the vertical axis rather than other goods consumption, and we can then use the trick from Chapter 9 to drop bundle A from the upper graph down to point A on the lower graph. Since the optimal bundle A happens in the upper graph at the price P1 bar, the A point on the lower graph will reside at the height P1 bar. We can do the same for bundle B, and since the price doesn't change between the blue and the magenta budget constraints in the upper graph, the point B in the lower graph will reside at the same height as point A. In Chapter 9, we kept income constant and changed the price of good 1 to derive a point C that we then also dropped to the lower graph in order to connect C and A to form the own price demand curve. Point A is therefore just one of the points on the own price demand curve that corresponds to an income level IA. We draw it here without estimating a second point, just indicating a general shape. The same is of course true for point B. Point B is simply one of the points on the demand curve that corresponds to an income level IB. Since the demand curve for the lower income level lies to the left of the demand curve for the higher income level, we've implicitly assumed that X1 is a normal good. In other words, holding prices fixed, an increase in income will cause this consumer to consume more of X1. In panel B, we'll now do something analogous for compensated demand curves, or what we've called marginal willingness to pay curves. And we begin with an indifference curve that we label UA. We'll label bundle A as one of the bundles that resides on this indifference curve, and we'll label the marginal rate of substitution at bundle A as MRS bar. We then choose a second indifference curve and label it UB. And we choose point B on that indifference curve as that bundle that has the same marginal rate of substitution as the one that we had at bundle A. We can then drop bundle A down to the lower graph, and it will reside at the height of that marginal rate of substitution MRS bar. If the indifference curves in panel B are the same as the ones in panel A, that MRS bar is also at the same height as P1 bar was in the first graph. This is of course because at the tangency at bundle A in panel A, the price P1 bar is equal to the marginal rate of substitution at bundle A, which is MRS bar. When we bring bundle B down to point B on the lower graph, it'll reside at the same marginal rate of substitution as bundle A, because they have the same marginal rate of substitution in the upper graph. We could now derive the full marginal willingness to pay curve that corresponds to indifference curve UA by bringing down the marginal rates of substitutions in the same way for different levels of x1. Instead of doing that explicitly here, we'll simply draw the blue marginal willingness to pay curve that contains bundle A. We can of course draw a similar marginal willingness to pay curve that contains point B in the lower graph, and that corresponds to the indifference curve UB in the upper graph. If you're rusty on how exactly we would derive such marginal willingness to pay curves, you can review the animations for graphs 10.1 and 10.2. Now notice what we've derived in the lower graphs of each of the two panels. In panel A, we have own price demand curves. Own price demand curves that differ depending on the income level, but along any given own price demand curve, income is fixed. It's held constant. In panel B, on the other hand, we have different compensated demand curves or marginal willingness to pay curves, different ones for each utility level or each indifference curve. Along any single marginal willingness to pay or compensated demand curve, utility is fixed, just as income is fixed along any own price demand curve in panel A. Own price demand curves tell us what consumers will actually do as prices change and their income is held fixed. Compensated demand curves are more hypothetical in nature. They tell us what a consumer would do if prices changed and we gave enough compensation to make sure that his indifference curve didn't change. And just as changes in income will cause shifts in own price demand curves, changes in the indifference level to which we compensate will cause shifts in the compensated or marginal willingness to pay curves.